Hello everyone, my name is Harshal Patil and today I'm excited to present my project on credit risk analysis. This project is focused on analyzing loan data to understand risk factors, default rates, and customer trends. Through this analysis, we aim to assist financial institutions in making data-driven decisions. So, the primary objectives of this project include calculating key financial metrics such as average loan amount, average interest rate, and default rate by loan grade, analyzing loan status distribution based on employment length and home ownership status, examining the relationship between income and loan amount to identify which loan intends have the highest loan to income ratio, tracking default rate changes over time using a personal credit history, simulating different scenarios based on interest rate changes and how they affect default rates, calculating a risk score for each loan considering values factors like income percentage, default history, and employment length, and then implementing the role level security to restrict data access based on their user role. Now, let's look how the objectives have been translated into an interactive Power BI dashboard. So here we have this dashboard. The first question asked was using index calculate the average loan amount and the average interest rate for each loan grade. How do these metrics correlate with default rate? So for that, what we've done is we've calculated the average loan amount, average interest rate, and default rate using the average function. Calculated the average loan amount and interest rate using the DAX, where you can see here we have the average loan amount, average interest rate, and default rate. To calculate the averages, what we've done is we use the calculate function where average of the person income, all x with the credit list loan intent. Then for the average interest rate, we calculate the average of interest rate. For the average loan amount, again we use the average function to calculate the average loan amount. So on to the next, we have we have to create a report visualizing the distribution on loan status across different employment lengths and home ownership status, which combination shows the highest default rate. So for that, what we've done, we created these two bar charts. In one, we have the loan status by person's years of working, and the other was loan status by the home ownership. So for that, we we created this bar chart, loan status by person years of experience, where we calculated the person employment length and the count of loan status. And for the home ownership, we created this bar chart where we have the person home ownership and again the count of loan status. So from that, what we found is the customer who have 1 to 5 years of experience has the higher default rate, whereas customer with 20 years and above experience has almost zero default rate. Customer who live in rented home or on mortgage have higher loan default rate compared to the customer who owns a house. On to the next one. We have we have to segment the borrowers of loan intent and visualize the average income and average loan amount for each segment, which intent has the highest loan amount to income ratio. So for that, what we've done, we created this table where we have the loan grade, average loan amount, average interest rate, and default rate. So the loan grade was from A to G. I calculated the loan grade, average loan amount, average interest rate, and default rate. So here, what we've done is we created this bar chart where we have average loan amount and average income, and then we have the loan income ratio by loan intent. So we created this segmentations and calculated the average loan amount and average according to average income, and also the loan to income ratio by loan intent. What we've done is we got the loan intent in the y-axis average of loan amount and average of income into the x-axis. And here we have the loan income ratio by loan intent, where we have loan intent and the loan income ratio in the values. And from that, what we have is the customer average income does not impact that much on loan amount. Customer with medical and education loan intent has higher loan to income ratio compared to the others. You can see here, customer with education and medical loan have the average loan amount more than the others. Here again, you can see the loan to income ratio was is about 0.15% compared to the others, which is on to the next one. We have to consider the CV person credit history as a time dimension, analyze how the loan default rate changed over years, implement a time slicer to adjust the view period. For that, we created this area chart where we have default rate over time by person credit history. Here we can see we have this area chart where we calculated the person's credit history and the default rate over time. So to get the default rate over time, what we done, we calculated the average of loan status. So and calculating beyond that, we got the default rate over time. And in the filter pan, we can see, yeah, we have the person credit history. What we've done is loan to income. We had added the average loan amount in 10 into the average income. Then we got the person credit history. And here we created this person credit history slicer where we can select the person's credit history. And on to the next question. Create a what if parameter to simulate different scenarios based on varying interest rate. How do changes in interest rates potentially affect the default rate? So for that, we have created this area chart where adjusted default rate by interest rate parameter. And here we created this line chart where we can calculate the adjusted default rate by interest rate parameter. And for the interest rate parameter, we created this slicer where we can adjust the interest rate. According to that, we can simulate the default rate. And for the interest rate parameter, what we've done, we created this interest rate parameter where gender series is to 525 to 05. It's and then for the parameter value, what we have done is we selected the value of interest rate parameter and intersect the rate parameter by 10. So we got this line chart to calculate the interest rate and calculate the adjusted default rate by interest rate parameter. On to the next question. If geographic data were available, how would you visualize the loan distribution and default rate across different regions? So for that, we don't really have the geographical data in the data set. So we just skip that question. On to the next one, which is write the DAX formula to calculate the risk score for each loan. Consider the factors such as loan amount, person income, default history, and employment length. Define the risk score formula based on this factor. So for that, we have created this was a bar chart where we have the average of person employment length, average of loan amount, and average of person income. So for the risk category, what we have done is we have created this risk category where we switch to risk score. If the risk score is greater than equal to 75, it's high risk. If the score is greater than or equal to 50, it's medium risk, or else it is low risk. And then we've got the average of person. Where we have the average of person employment length, average of loan amount, and average of person income. From that, we calculated the loan risk score according to the person employment length, loan amount, and person income. Here we can select the risk levels: medium risk, low risk, and high risk. From that, what we have is customer higher income get more loan, but they also have higher risk percentage. Customers with low income get less loan amount, so they have low risk as well. So the next question was implement a row-level security to ensure that user can only view the data relevant to their specific region or department. How would you set up the course for that? What we do is we go to modeling. Here we go to the manage roles. Here I've created the owner role where only the owner can access the data. And have created this owner where the person who ownership is owned and then close. So that's how we can implement the role of security into the dashboard. So the next one was to design a comprehensive dashboard that include all navigational feature and tooltips. How would you publish how will you publish and share the dashboard with stakeholders in Power BI services? Focus area is dashboard design, application, and all. And then we created this interactive dashboard where we have the risk score, when we have the loan intent, home ownership, and then we included all the charts we have created. So from that is all we just have on previous data analysis. So from according to the all the dashboard and all the chart, we have some, some key insights. Employment length is a stronger predictor of loan default risk. Borrowers with less than 5 years of experience have higher default rate. Home ownership significantly reduces the credit risk. Renters and mortgage holders tend to default more compared to the homeowners. Loan intent matters. Medical and education loans have higher loan-to-income ratio, indicating financial stress on these categories. Credit history directly impacts default probability. Customers with shorter credit histories have higher default rates. Higher interest rates correlate with the higher default rate. This means that default risk increases. Lenders charge higher interest rate to mitigate the losses. Risk scoring can help financial institutions make informed lending discussions by accessing the factors like income, employment stability, and credit history. To conclude this dashboard, we provided in-depth analysis on credit risk factors using Power BI, helping financial institutions identify high-risk borrowers and make informed decisions. And for the future improvements for this project could include enhancing the predictive analytics using machine learning modules to analyze the risk forecasting and adding more interactive filters to the low intent dynamically. So thank you for watching my presentation on credit risk analysis. I hope this provides valuable insight on how data analytics can optimize financial decision making. Thank you.